Alright, this video is about scientific notation. Scientific notation is a way to write really big or really small numbers in a more manageable format. So, I'm going to show an example here, okay? So, let's say I had the number 24 billion. Now, the reason I know this is 24 billion is because it has 9 zeros. So if it had 3 zeros, it'd be 1,000. If it had 6 zeros, it'd be 1,000,000. If it had 9 zeros, it'd be 1,000,000,000. So I can tell just by looking at this is 24 billion. Now, let's say I was doing some calculations. It's really inconvenient to have to write 24,000,000,000,000,000 over and over again in your calculator or your computer or, God forbid, by hand. So here's this is a little trick, okay? Scientific notation, it was developed for the purpose of saving time. Keep that in mind. So I'm going to rewrite this. So what I'm going to do, the steps to doing scientific notation, is what you do is you look for the part of the number that has, that contains the information. It contains the actual numbers instead of just a bunch of zero. See what I'm saying? So in this case, it's 24. So I'm going to write 24. Now, what I'm going to do is I'm going to count the number of zeros after that point where I cut it off. See what I'm saying? See, if I put my pin right here, 24 is to this side of it, and all the zeros are to the other side. I'm going to count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 zeros. So then what I do is I go times 10 to the 9th. Now why did I do that? Well, because 10 to the 9th is equal to 1 billion. So really, what I'm doing is I'm writing out in a sort of an expression that says 24 times, whoops, it's supposed to be 0, times a billion. So 24 times a billion is just 24 billion. So that's a little proof that this expression here is equal to that same number. So that's what scientific notation is. It's just a different way of writing numbers. All right. So this is when you use it for really big numbers. Now what about really small numbers? It actually works the same way. So let's say I'm going to make a little barrier here. Let's say that I had a number that was like this, 0.000573. Okay, if I want to write this in scientific notation, what I'm going to do is I'm actually going to first choose a place where I would like the decimal place to be. So let's say that I wanted to rewrite this scientific notation. I wanted to rewrite this number in scientific notation using 5.73. That's kind of a common thing to do, is just have the decimal place be 1 to the right of the first number and then have the decimals following it. But in order to do this, I need to know now what the exponent is going to be on this 10. So see how I have the decimal place between the 5 and the 7? That would correspond to right here. So I'm thinking about I want to think about how many spaces I had to move to get there. So the decimal place is really here. I moved the decimal place to here in my scientific notation, right between the 5 and the 7. So to get there, I had to count 1, 2, 3, 4 spaces. So because I had to do that, I need to put a -4 on the 10 as the exponent. Let me explain kind of why you put the negative right there, okay? Well, it turns out that raising anything to a negative exponent makes it smaller. It makes it get smaller. And you'll notice that this number, 0.000573, is actually very small. It's a minute decimal. This number, 5.73, is actually very large compared to this. So what I need to do, this 10 to the -4th, this is the smallness part of that number. So just like I used 10 to the 9th up here to make 24 really big, I'm going to use 10 to the -4 down here to make 5.73 really small. So let me just kind of go over these rules one more time. So for a large number, what you do is you put your decimal place right after the numbers that you want to keep in your initial part, okay? Then you just look at how many zeros are after it. In this case it was 9, so I went times 10 to the 9th. For small numbers, what you do is you write out the numbers like this. You look at the very end of the decimal and you look at the numbers. You put your decimal place right between the first two numbers in that sequence. That's the standard way to do it, right? So I get 5.73. Then you just consider the number of spaces that you needed to move in order to get to that place. In this case, it was 4. So I went 10 to the negative fourth, because 1, 2, 3, 4 to get there. So that's basically it. Now, let's think about going backwards now, right? What would happen if they gave you a problem like this? They said, convert 2.6 times 10 to the negative fifth to expanded form. So they just want you to write it in normal form. This is in scientific notation right now, and you have to write it as a normal number. So in this instance, what you do is you take 2.6 and you write it down. All right. And now look at this expression here. You see how this is 2.6 times 10 to the negative fifth? What this means is that since it's a negative exponent, I'm actually going to be writing down a really small number here. And since I'm writing down a small number, I need to take the decimal place and I need to count actually to the left. That's the rule. If I have a negative exponent, I count to the left when I'm converting into a normal number, because I need to create a lot of zeros here in order to make this small, because this is very small. So what I do is I go 2.6, I write this down, and I look at the exponent, it says negative 5, so I just count negative 5 to the left. 1, 2, 3, 4, 5. So now this is the new location of my decimal place. And what I'm going to do is I'm going to kind of fill in zeros at all the spaces. So, and I'm going to put a 0 out front, okay? So it's 0.000026. The decimal place is not here anymore. So if I rewrite this, it's just 0.000026. This is equal to 2.6 times 10 to the negative fifth. You'll notice, see, if I went 1, 2, 3, 4, 5, I would get back to this in the procedure that I used to do when I did this problem. So anyways, that's basically it. I guess we can do one more example, because I just want to make sure that I'm not doing too much theory here and not enough examples. I'll do another example involving the large numbers that we did up here, okay? But in this case, we'll try to convert from scientific notation to the normal form of the number. So let's say that I had a number like, I don't know, how about 43 times 10 to the third? Well, this is actually pretty easy. What I'm going to do is I just want to think of this 43 times 10 to the third as 43 times 1,000. Because 10 to the third is 1,000, isn't it? It's just a 10 followed by 3 zeros. Or, excuse me, a 1 followed by 3 zeros. Boom, boom, boom. So, 43 times 1,000 is just 43,000. Now, you don't have to think of it this way. You could just do the decimal place counting method, right? If you go write down 43, and start here at the end and count 3 decimal places to the right. See how I would still get 43,000, but there's a little comma right here. But I don't know, whichever way works best with your brain to be able to understand this is I mean, they're both equivalent mathematically, so it's just a matter of personal preference. Anyways, I hope you thought the video was informative. I feel like I kind of went all over the place there, like a lot of my videos. So hopefully it was helpful, and please check out my other videos, and let me know what you think. And if you want to leave some, like a question in the comments, assuming I don't get too many of them to handle, I would be happy to try to get back to you and help you out there. So thanks for watching.